In plate tectonics, sometimes plates run into each other. I mean, literally collide with each other. We call that a convergent boundary. And you think about two cars hitting head on. Typically what happens is there's a lot of force involved and there's a lot of changes that take place. The same with continents or crust when they crash into each other. With convergent boundaries, there's three types of convergent boundaries. Continent to continent, when the less dense continental crust crashes together. Continent to oceanic crust, when the less dense continental crust crashes into more dense oceanic crust. And then sometimes we have ocean crust crashing into ocean crust. So keep in mind that somewhere on the planet, if plates are diverging, moving apart, then somewhere else on the planet, plates are running together. And something's got to give because the Earth is not getting bigger and bigger and bigger as more crust is made. So for every millimeter of crust that is created by upwelling from the mantle, there's a millimeter of crust that is actually being remelted somewhere else on the planet. And that remelting takes place at convergent boundaries. In a continent-to-continental crust collision or convergent boundary, typically mountains form. You can think of this like a car running into another car. When the cars come together, most often it happens is the fronts of the car push upwards. You can think of that as mountain building. I mean, that's a violent example, but really continent-to-continental collisions are very violent. They're very slow motion car wrecks, if you think about it like this. It's more like something's pushing two cars together very slowly, continuing to push them together, causing mountains to start to build. An example of this are the Himalayan mountains. Himalayan mountains are continuing to grow, amazingly. What's very interesting is that at the tops of the Himalayan mountains, you can find fossils of creatures that used to live in seawater. Ammonites, for one. What that tells us is either the oceans used to be a lot deeper or the area of the Himalayas used to be a lot lower. Measurements show that the Himalayas continue to rise slowly but surely. We think this is due to the fact that India crashed into the Asian continent many years ago. And as the Indian landmass collided with the Asian landmass, it created a continent-to-continent collision, resulting in the Alps as a mountain range. In continent-to-oceanic crust collisions, typically what happens is the continental crust, being less dense, has a tendency to stay aloft, while the oceanic crust dives underneath the continent. When oceanic crust dives underneath continental crust, it does create a subduction zone. The subduction zones typically result in a trench below water level and also a series of volcanoes. Typically, mountains occur. For instance, the Andes Mountains in South America are a result of oceanic crust diving beneath continental crust, resulting in volcanic activity. When ocean and ocean plates collide, both of those plates are very dense, so something's got to give. So typically what happens there, one or the other results in a melting process known also as a subduction zone. This can result in a trench. For instance, the Marianas Trench, these are very deep areas where one plate slides beneath another plate, creating a very deep area. The Marianas Trench is about 11 kilometers deep. Here's an example of the Marianas Trench. If you look closely, you'll see that some of the deepest points in the ocean on a map are associated with subduction zones of oceanic plates and oceanic plates colliding with each other.